Hello everyone, so today I'll be discussing question number 33 of GATE 2016 set 2. The portal frame shown in the figure is subjected to a uniformly distributed vertical load W per unit length. The bending moment in the beam at the joint Q is. So we need to find the value of bending moment in the beam at the joint Q. So 4 options are given to us. For this type of problems, you can refer to lecture series on structural analysis 1 by Professor Amit Shaw, Department of Civil Engineering, IIT Kharagpur. It's a 2-mark question with negative marking. Now let's start with the solution of this problem. So here is the portal frame which is given to us. So let us first find out the reactions. So it is a determinate problem, so we can easily solve this problem by drawing the free body diagram. Okay, so first of all, let us find the reactions here. So what are all the possible reactions? So here it will be Vp, that is the vertical reaction at P. Here it is HP, horizontal reaction at P. Here it will be Vs, vertical reaction at S. There will be no horizontal reaction here. Why? Because this support S is not restrained against horizontal movement. Okay. So these are all the possible reactions. Now it is a symmetric structure and the loading is also symmetric. So Vp and Vs will be equal and this load WL, the total load WL will be distributed equally among these two supports. Okay, so Vp will be equal to WL by 2, that is half of the total load, and Vs will also be equal to WL by 2. Now HP will be equal to 0 here. Why? Because there is no other external horizontal load which is applied. So in order to satisfy the horizontal equilibrium, this HP has to be 0. So globally all the equilibrium is satisfied here. Now let us solve this problem by using the free body diagrams. So let me draw separately the beams and columns. So here is the column RS. Here is this beam which is QR. Okay, so let us name them. This is R and S. Okay, so starting from S, we have this Vs here. So it is WL by 2. Okay, other than this, there is no other force at S. So it is upward WL by 2. So at R, it will be downward WL by 2. Okay, so vertical equilibrium is satisfied. There is no horizontal force and there is no moment as well. So everything is done for this column RS. Now let us shift to this beam QR. Okay, so this force is in downward direction. So here it will be upward WL by 2. Let us make this UDL also. So this UDL has magnitude W per unit length. So the total force here, vertical force here will be WL in the downward direction due to this UDL minus this WL by 2. So minus WL by 2. So a total force which is vertical force which is unbalanced here is WL by 2. So let us mark here WL by 2. So now the vertical equilibrium is satisfied. If you see, the total downward force due to this UDL is WL and total upward force due to these two is WL by 2 plus WL by 2, that is WL. So vertical equilibrium is satisfied. There is no horizontal force. So now let us find the moment at this joint Q. So moment at Q will be equal to the moment due to this vertical force WL by 2. So let us consider clockwise as positive. So this will produce anti-clockwise moment. So minus WL by 2 multiplied by L. Okay, and this UDL will produce clockwise moment. So plus W multiplied by the length over which it is acting, that is L, multiplied by the distance between this joint and the CG of this load multiplied by L by 2. So moment at Q will be equal to minus WL square by 2 plus WL square by 2. So finally moment at Q is 0. So here we got our answer now. The moment at Q we are getting as 0. Although at this stage we have got our answer, and that is moment at Q, but still we can also make we can complete this free body diagram by making the forces in the other column as well. So let me draw this column here. Yeah, so here we have this WL by 2 in upward direction. So this is column QP. For this we will have it in downward in direction, WL by 2. There is no moment at joint Q, so it will not get transferred here. There is no horizontal force here at joint Q, so there will be no horizontal force getting transferred. Now let us satisfy all the equilibriums for this column QP. So at this end it is downward WL by 2. So at P it will be upward WL by 2. Other than this, there is no horizontal force and there is no moment. So we can see, so we have made the free body diagram for all the columns and beam. We can also confirm verify here if we see the joint P here. So there is VP which is having the value WL by 2, and we are getting the same value by a free body diagram as well. There is HP which is having value 0, and we do not have any horizontal force here in the free body diagram as well. And the VS is WL by 2, and VS here is also WL by 2. So we can at last verify also, but at this stage we only needed to find the value of moment at Q, which is coming out to be 0. So the final answer here will be this A, option number A.